Okay, now we're in section 2.2, measured numbers and significant figures. Measured numbers are numbers you obtain when you measure a quantity, such as your height, weight, or temperature. In chemistry, you will typically measure the mass of an object in grams or kilograms, the volume of an object, usually in milliliters, in chemistry at least. Temperatures, well, you'll measure it in degrees Celsius, but if you're using calculation, you'll convert it to kelvins. You'll measure pressures, which can be in atmospheres or millimeters of mercury or torrs, bars, kilopascals. In America, we use PSI, pounds per square inch. And then you can measure time, seconds, hours, days, minutes, whatever. Now, significant figures are all of the digits in a measured number, including the final digit, which is the estimated digit. So if I were to weigh, let's say, my cell phone on a balance, it might say that it weighs, let me say, I'm making it up, but I'm trying to make it a reasonable number. Let's say 300.4869 grams. That number 9 is going to be the estimated digit. You might look at any balance and you'll see the last number there, on a digital balance I should say, is going to fluctuate. It might go from 6.9 to 6.8 all the way down to 6.6. It might jump up to 7.4870, 0.4871, and you'll see it fluctuate, and eventually it'll just stop fluctuating and give you something, but it is still the estimated digit. Essentially, the computer in the instrument is unable to really identify what it is. It might be 0.48685. Let's say, so let me write that down. 300.48685, which is one digit beyond where this estimated digit is. If you look at it, that rounds to 0.4869. It could be 300.48693. Let me put the units in. But that would still round to 300.4869 as well. The last number here, which is not shown on the computer, is basically too small of a unit for the precision of the instrument, and so it has to round it, and therefore that last one it shows is just an estimate. But this 300.4869 has, it has 1, 2, 3, 4, 5, 6, 7 significant figures, or 7 Sig Figs, as we call it. Okay. This table here shows some of the rules for how many significant figures a number has. And then the next couple of slides have them more specifically defined. But rule number 1, a number is significant if it is not a 0. So, for example, these numbers here, 4.5 grams has 2 digits, the 4 and the 5. None of them are zeros, so both of them are significant. It has 2 significant figures. 122.35 meters is all non-zeros, so all of them are significant, so it has 5 significant figures. A number is significant if it is a 0 between non-zero digits. So, for example, 205 degrees Celsius has 3 significant figures. The 0 is between 2 non-zeros and therefore must be significant. In 5.008 kilograms, both of the zeros are in between 2 non-zeros and therefore are significant. Rule 1C, a number is significant if it is a 0 at the end of a decimal number. So, as you can see here, there's 50 point liters, or 50 with a decimal liters, that has two significant figures as written. Your book will like to use this form. Most books don't do that, but your book likes to do that. This is standard notation for writing numbers while including the number of significant figures at the same time. So that if you see a decimal there, let me write a number here that's not on there, but if I have, let's say 3 million, and I put a decimal at the end of it, that would have 1, 2, 3, 4, 5, 6, 7 significant figures. Because of the decimal being there. Now the next one there is 16.00 milliliters. That one has the zeros after the decimal and after a non-zero. To the right of non-zero numbers and after decimal are always significant. What is not in here would be a better example of a number like, let's say, 0.30. This has two significant figures because we've got the 3 and we've got a 0 to the right of it after the decimal. But the 0 in front is not significant. What about if I have a number like 0.030? This one still has two significant figures. The front two zeros are not significant. So 0.030 also has two significant figures. 1D, a number is significant if it is the coefficient of a number written in the scientific notation. The numbers right here are written in scientific notation. What that means is you have a number that is a non-zero, immediately followed by a decimal, and then the rest of the significant figures. Then times 10 to some power. So you'll never have a number, let's say like 93.4 times 10 to the third. That's really 9.34 times 10 to the fourth. That's the correct way of writing in scientific notation, not this. I erase all that stuff because it's getting messy. But 1D here, 4.8 times 10 to the fifth, has two significant figures because you have a 4 and an 8. And 5.70 has three significant figures. The 0 is after the decimal, after a non-zero number, so it is significant. 2. A 0 is not significant if it is A, at the beginning of a decimal number. So as you can see here, I mentioned it a little earlier, but 0.0004 seconds has one significant figure. The 4 zeros in front of it are not significant, but the 4 is. The next one there, 0.075, has two significant figures, the 7 and the 5. The two zeros to the left are not significant. And then 2b, a 0 is not significant if it is used as a placeholder in a large number without a decimal place. So for example, 850,000 meters, since that one does not have a decimal place, you can see or a decimal point, I should say, it only has 2 significant figures. Now, I would say that this table is not all-inclusive. There are cases where 850,000 meters might have 3 significant figures, it might have 4, it might have 5 significant figures. It might even have 6. But if it's 6, it would have a decimal place after it. The thing that makes it so challenging is that sometimes the context of the question will dictate how many significant figures a number like that has. If it happens to end up to such a whole number with a bunch of zeros. But the number by itself, with no context, here's a number, how many significant figures does it have? Knowing nothing else about it, it has 2. And then the second one there, 1,250,000 grams, has 3 significant figures, the 3 in front of it. The rightmost zeros are not significant.